Hey everyone, Mr. Newman here, and we're just going to do a few review problems for 6.1 and 6.5. We're also going to end with a problem that is a little more difficult than you will see on the quiz, but I think it's a good practice to try more difficult problems. That way the quiz seems easier by comparison. So, let's get started. First of all, for 6.1, we have for one taxi company, the cost Y in dollars. That's good, we already know Y is cost. Of a ride is a linear function of the miles traveled. So X is miles traveled. The initial charge is $2. Initial charge suggests our starting value or our y-intercept. And the charge per mile is 40 cents. That per mile tells me that is rate of change or slope. So the rest of this just says identify the slope and y-intercept and to say what they mean and then write an equation, and that's what we're going to do. So we know slope is 0.4 because 40 cents is how much they charge per mile. And that means how much the ride costs each, each mile, because miles is the, each mile, there we go. Miles is traveled is your X value. For the y-intercept, that's our initial value, so that's $2, initial charge is $2, and that means how much the ride costs to start. So before you drive anywhere, as if you sit inside of a taxi, it costs $2 just to get inside the taxi. For our equation, we remember that y equals mx plus b is the slope-intercept form. So since I know slope and I know the y-intercept, I just put 0.4 for slope, because that's the slope, and instead of m. And then instead of b, I'm going to put 2, because that's the y-intercept. So the cost of riding 15 miles, we remember that miles traveled is X. So that means that 15 is X, and plug that in right there and you get $6 plus $2 or $8. Now, one thing I forgot to mention on this whole video, please try each of the problems before watching the video. If you get stuck, start watching the video until the point that you get unstuck, and then see if you can do the rest on your own. All right, so $8 is the answer to the first one for the cost of riding 15 miles. And that's how we found out the equation, slope and y-intercept. For the next two problems, we're going to write an equation of each of these lines, and you guys should all be able to do this, so please try this first. Notice that our equation is still y equals mx plus b. M is slope, x is 3, y is 6. So we write down y equals m, which is 4, times x, which is 3, plus b. We're looking for b, so I'm going to fill out all the parts of the equation until we get b. So 6 equals 12 plus b, and subtract 12 from both sides, we get b equals negative 6. So plug this into our equation. We have y equals m, which is 4, x plus negative 6. In other words, minus 6. So y equals 4x minus 6 is our final equation and answer for that first one. All right, for the next one, what if we can have just 2 points? Well, we know how to find the slope from 2 points. So I'm going to make my table of values, fill out the 2 points. The nice thing about this is, look, they're both plus 4, so if I forget which one goes on top, I'm safe because it'll be the same either way. But you should remember that y, delta y goes on top and delta x goes on the bottom. So 4 over 4 is 1, and that is our slope. So if we know slope, let's just pick a point. I picked 5, 0 because those are easier numbers than 9 and 4. And 0 equals y equals m, which is 1, times x, which is 5, plus b. I plugged in y equals m and x, and we're solving for b. So 1 times 5 is 5, subtract 5 from both sides, and you get b equals negative 5. So our equation is y equals 1x minus 5. You can also write y equals x minus 5 because the 1 is implied. All right, for this word problem, Jan works from 30 to 40 hours per week during the summer. She earns $12 per hour. Her friend Rachel also has a job. Rachel's pay for t hours is given by this function. R of t equals 11 times t, where 20 is less than or equal to t, which is less than or equal to 30. First thing they want us to do is find the domain and range of each function. Well, and then compare the hourly rate wages. What I'm going to do is I'm going to make 2 tables, one for Jan and one for Rachel. That's going to help me find the domain and range. It said Rachel worked from 30 to 40 hours, so I'm going to put 30, that's, remember, the x value. and go all the way up to 40. And I'm just going to put down 35 because that seemed like a good stepping stone from 30 to 40. Then Rachel, it gave this little inequality. 20 is less than or equal to t, which is less than or equal to 30. Well, that's another way of saying from 20 to 30. So I'm going to go 20, 25, all the way up to 30. Jan earns $12 an hour. That means we're going to take the time, x, and multiply that by 12. 30 times 12 is 360, all the way to 40 times 12 is 480. For Rachel, it gives us the equation. That's almost the same thing, except we're multiplying by 11. So take 20 and multiply 11, and take each of those and multiply by 11, and we get the output. Now, that means that the domain for Jan's job is from 30 to 40, and that's how we write that in interval notation. The output, or the range, is from $360 all the way up to $480, and that's how much she could earn each week. For Rachel, the domain goes from 20 to 30, again, and that's including 20 and 30, and the range goes from 220 to 330. So compare their hourly wages. Well, we know that Jan gets $12 each hour, and that equation, 11t, means Rachel gets $11 per hour because that's the slope. When it says the amount they earn per week, well, that's just this range here. So Jan earns between $360 and $480 per week, while Rachel earns between $220 and $330 per week. So no matter what, Jan always earns more than Rachel. But that's because her job is both higher paying and she works more hours. Okay, on to the back. This is the most difficult problem, and one of the reasons it's difficult is because if you look at the situation, let's read it real quickly. There are two functions, and they're not even using the same units. But let's read this first. Jamal and Kendra are running a 26.2-mile marathon. Jamal's friend is recording his times in the table as shown, while Kendra's friend uses a scatter plot to show her progress. If both runners continue at the same average pace, who will arrive at the finish line first? How much longer will it take for the other person to finish? Well, what we're going to do is we are going to figure out how fast they're going in different sections. But the problem is, you notice Jamal's race goes from miles and minutes, and Kendra's is talking about miles and hours. So first thing I want to do is make a table of both of these runners. Jamal's table will be on top, Kendra's will be on the bottom. There's time and distance. Time is the x for Kendra's graph, and distance is the y. But look at Jamal's table. His friend was recording every mile, so his x and y are switched. So first thing I'm going to do is I'm going to switch those back just so we can compare them more easily. So time and distance, we're going to switch those. So time is the x, and it's in hours, and distance is the y. Well, to turn that into hours, we're going to have to do a little bit of math, okay? If you have 26 minutes, to find out how many hours that is, you divide by 60. So 0.43, it's actually 0.433333, but I'm just going to round to 0.43 for now. 0.43 hours is 26 minutes, and that kind of makes sense because 26 minutes is less than half an hour, and so is 0.43 is less than half of 1. The distance for 0.43 is 4. Now leave a little bit of time above that on the graph. You'll see why in a little bit. We calculate the rest of these by dividing by 60, and we get each of these values for the times. Now, for Kendra, one last thing. The reason that I wanted you to leave space at the top is because we also know a time that wasn't recorded. We know that at 0 minutes, in other words, 0 hours, that the distance was 0. Why? Because he started the race at time equals 0. So we know 0, 0 is a point. Let's go ahead and put that down for Kendra. Even though that's not a point plotted, we know it's a point on the graph. So at 0.5, that looks like it goes halfway between 2 and 4, so I'm going to put down 3 for the distance. At 1, again, halfway between 6 and 8 is 7, and so forth, and so on and so forth, all the way up to 2.5, 16. Now, how fast is Jamal running from 0 minutes to 26 minutes? Well, that's this little section right here, this first blip. So I'm going to record and figure out how fast we're going from 0 to 0.43 hours, and we do delta y divided by delta x, and you get 9.3 miles per hour, because that is miles on top divided by hours on the bottom, so miles per hour. Kendra, and that's pretty fast actually, Kendra she's going from 0 to 0.5 hours. She's going 3 miles in 0.5 hours, so 3 divided by 0.5 is 6 miles per hour. Way slower. But hold on, we're not done yet because we need to measure how fast they're going later in the race. Later in the race, Jamal going from 128 minutes to 170. Those are the last 2 points that we recorded. So, if we look closely, that's going from the 2.13 to the 2.83. That's up by 0.7. And the distance is up by 4. So 4 divided by 0.7 is 5.7 miles per hour. So Jamal really slowed down later on in his race. Now this is going to be a little tricky because we don't have a linear function that fits all of this data. We're going to explain what we're going to do about that at the end. But we know it's not linear because it's not a constant rate of change. The rate of change just changed from 9.3 to 5.7. That's not constant. Let's find Kendra's rate of change here. Hers stayed 6 miles per hour, but if you look at her graph, if I tried to connect her points, you guys see how that makes it zigzag a little bit? Okay? That zigzag means that she's also not at a constant rate of change, even though her first set of rate of change and her last rate of change are the same. In between, she doesn't have the same rate of change. So what we're going to do for this next question, it says, you find a line based on the last 2 points. I'm going to take the slope that we just found from the last 2 points, and I'm going to take the very last point, and I'm going to use those to calculate and figure out an equation, much like we did before. So I'm going to write down y equals mx plus b, and I don't know b, so I'm going to solve for it. So 3.9 is b. So my equation is y equals 5.7x plus 3.9. That's an equation for Jamal. What I'm going to do, since we're running out of time and I'm running out of space, is I'm going to let you figure out Kendra's equation, and then I want you to try and answer that last problem. And here's the deal I'm going to make. This is only for students who listen to my recording, not because I'm not going to write this down anywhere, so you have to listen very carefully. If you finish all of these problems at the end and you get these last 2 problems correct, then you should staple this to your quiz. Because if you staple it to your quiz, if you don't get a 3, don't get 100, I will bump up your number by 1. In other words, if you staple this to your quiz and you get a 1 on your quiz, I'll bump it up to a 2. If you get a 2 on your quiz, I'll bump it up to a 3. If you already have a 3, there's no 4, so you get to stay at a 3. But in that sense, this quiz will kind of be a guarantee of raising your grade 1 number if you finish it. So finish this and staple it to your quiz. I will probably not remind you. It's just for the students who hear this message and remember on the day of the quiz. So don't have this out while you're taking the quiz, but once you finish the quiz, you can go over to your book bag, take out the quiz quietly, staple it, and turn it in with your quiz. That way you can get that bonus point for finishing this assignment. Thank you very much, and have a good day.